All right, guys, here we go. Last lesson this week. All right, so now we're on lesson 116, factoring algebraic expressions. Hopefully for 115, you guys saw, I put it in the email that you only need to know one new conversion there, and that's it. That should help you do all of 115. So if you have questions about any of that, I didn't make a separate video because it was very basic. The information given in that one didn't even feel like it really needed a video. So if you have questions though, please save them and ask me in class on Thursday, and I would be happy to help you with those. Okay, so we're moving on to 116, factoring algebraic expressions. Okay, so let's talk about that a little bit. So factoring is something we haven't done a whole lot of, but you will be doing a whole lot of coming up. So like we talked about in lesson 114 when we did graphing linear inequalities, and I said this is something you're going to do in Algebra 1. Same thing here. This is something you're going to do in Algebra 1. Then you're going to do it again in geometry. Then you're going to do it again in Algebra 2. It just keeps coming. So make sure that you pay close attention, okay, to really grasp what we're doing here. I know you guys will understand it. You have factored in terms of like factoring numbers and breaking down like when we do prime factorization, that whole upside down division thing, you guys are very familiar with that. I know you know how to do that well. So that's the factoring concept, okay, that we're going for here. And we will actually be using that prime factorization a little bit in what we're doing today. Okay, so let's look at, first we're gonna do a little vocabulary, okay? Let's talk about two different types of values that we would factor. So this lesson is called Factoring Algebraic Expressions. Algebraic expressions can be made up of monomials or polynomials, okay? So monomials, I always encourage you guys to think context clues here with your prefixes. So mono, okay? Everybody always thinks about the kissing disease when I say that. That's not what I'm talking about. So actually it is it could, if you really go through, anyway, whatever. That's not the point. It's easier if you think about like a monocle. You guys know what a monocle is? Like my son loves to play around with a monocle. Like he'll break an eyeglass in half so that he can pretend he has a monocle. I don't know what's cool about that, but he thinks it's cool. That's it's called a monocle because it's one lens, single one. Okay, a monomial is one term. Okay, so it is an expression with one term. Okay, that is what a monomial is. So examples of a monomial would look like, I'm on the wrong page, would look like 6x squared y cubed, 5xy over 2w, and -6. Now, you may be thinking, okay, I'm with you on the -6, but these are monomials. It's true. These are monomials because when we see no addition or subtraction separating the values, when they're all squished together, we treat it like it's one term. This counts as one term. This counts as one term. And this one's easier to see, but it counts as one term, okay? So these are all examples of monomials because there is no addition and subtraction separating the values, okay? It is all squished together into one package, into one term. So these are monomials. Polynomials, on the other hand, poly means many, okay? So, let's see. So if we want an example of polynomials, that could be 3x squared y, which that's a monomial. But if we say plus 6xy squared, this whole expression is called a polynomial, okay? Or we could put it in parentheses to help us better see that. Another polynomial would be x squared plus 2x plus 1. And another one would be 3a plus 4b plus 5c plus d. Now, some of these we can actually label even more specifically. So a monomial is one term, a one-termed expression. Now, a polynomial, some of them can be broken down. This one only has two terms, so we would call it a binomial. Again, prefixes, bi, like bicycle, has two wheels, right? A 3 1, 2, 3 termed expression can be also called a trinomial. Tri, like tricycle, has 3 wheels. My baby likes to ride his tricycle, but he doesn't really know how to use the pedals, so he just takes his little feet like Fred Flintstone and just goes down the sidewalk on his tricycle with 3 wheels, okay? So that is a 3-termed expression. Now, these still all fall under the umbrella of a polynomial, okay? We can make it a little umbrella if we want. Okay, so they all fall under the umbrella of a polynomial, but more specifically, you could label them binomial, trinomial, etc., okay? When we get higher than 3 terms, we usually just call them polynomials. We don't want to go into all these quadrinomials and whatever. Okay, so let's move on. Now we are going to look at what this factoring actually looks like. So if we've got a monomial, this would be a monomial that we're wanting to factor, then all we really need to do is think about breaking down the number and breaking down the variables, okay? So 2 things you want to break down, which factor means to break down, okay? So we want to break down the numbers, break down the number, and then we want to break down the variables. Okay, so, all right, so 6, like I said earlier when I referenced prime factorization, I know that 6 can be broken down into 2 and 3. Those are both prime numbers. So anytime you're breaking down the number, you want to break it down into prime numbers. So 2 and 3 is how we would break that down. Now we know x squared really just means x times itself. So x times x. Y cubed just means y times y times y, okay? So that is all we need to do here whenever it asks us to factor a monomial. We are just breaking it down, okay? An extra step would be if you've got a polynomial, which this has 2 terms, so we call it a, very good, binomial, because it has 2 terms, binomial. Okay, so we are going to break this one down. Now, 3 is already a prime number, so we don't have to do anything to that. We're going to keep that one as 3, okay? X squared, same way we just broke that one down into x, and then y just stays y. Now, 6, we just broke that one down, so we know how that breaks down, 2 and 3. And then we've got x and y, y, okay? So now we want to look at, are there any common factors in those 2? Because if there are any common factors that they share, we want to take them out, okay? So that's an additional step whenever you've got more than 1 term. So if it's not just a monomial, you have to break it down, but then make sure, step number 3 in these, you look for common factors, okay? And in fact, whatever we pull out, whatever we ultimately find, that's actually called the greatest common factor. So we see that both of these have a 3, they both have 1 x, and they both have 1 y. Okay, so that means that I am removing from both of these a 3xy, okay? So when I remove the 3xy from here and the 3xy from here, now I just have to list what's left. So once I remove that from this first term, all that's left is just an x, this one right here, right? When I remove those values from the second term, all that's left is a 2y. So that 2y stays inside the parentheses, showing me what's left, okay? So this would be fully factored form of the original binomial that they gave us. Any questions? Any questions like you guys are going to ask me. I'm just so used to saying that. All right, so also just a note, this value that comes out is called the greatest common factor. Okay? Just a little more vocabulary for you there. And I think actually that is all. Oh, just kidding. We have, do we have one more? Yes, we have a couple more examples. Yay. Okay. Let's keep doing this a little bit more. All right, so let's look at this one. We want to factor this monomial. Okay, so same thing. We're going to break it down. So we know that 12, now if we wanted to actually do our whole prime factorization thing on 12, we could say 12 divided by 2 is 6. 6 divided by 2 is 3. So these are our prime factors. Okay, so we've got 2, 2, 3, and then we're breaking A down into A and A because there's 2 of them. And then we've got 3 B's, B, 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 and C. It's a lot, but that's how it breaks all the way down. So we got to make sure we do the whole thing, okay? So that's it, simple for monomial. You just break it all down. And now let's look at the last one. We're going to do another polynomial, this time a trinomial. So we're breaking down all 3 of these monomials, and then we're looking to see if they have anything in common, okay? So we know 6 breaks down into, oops, my finger got in the way. 6 breaks down into 2 and 3, and then A squared would be A, and then we've got the B, okay? So that's our first term. Now we're looking at our second term. So plus 4 breaks down into 2 and 2, and then we've got 1A and 2 B's on that one. Okay, now I'm running out of room, so I'm going to put the last one down here. So I've got 2 and then an A and a B. So now I'm looking for anything they share. So I see all 3, and it has to be all 3 of them. All 3 of them have a 2. They don't all 3 have a 3. They do all 3 have 1A. And they do all 3 have 1B. So that tells me I'm taking out 2AB, okay? So that is going to be removed from all 3 of these, okay? So that leaves me with, in my first one, all I have left is the 3 and the A. So that's a 3A. In the second one, I've got a 2 and a B. So that's a 2B that's left there. And then in the third term, everything went away. But I have to maintain a placeholder. This is super important, okay? I see students make this mistake all the time. Don't say, oh, they all went away, so I can just, done. But if you were to redistribute this, that would not work. You wouldn't have anywhere for it to go, okay? So we can't do that. We have to have a placeholder, which an excellent placeholder is always one singular sensation. Okay, I won't sing for you guys, but that is it. All done. Have a great week, you guys. Happy homework. Make sure you think about your steps here, breaking it down, and then looking for any common factors that you can take out. Remember, this value right here is known as our greatest common factor, okay? And then you list whatever's left. You guys got this. I'll see you Thursday.